everyone, welcome once again to Subject Matter. Today we'll continue the other aspect of simple AC circuit. So here we have AC circuit containing resistor and capacitors. This is what the circuit diagram looks like. Here is our resistor. This is our capacitor. This symbol represents alternating current. Here we have our voltage connected in parallel with the resistor. So this voltage across the resistor, the subscript R means resistor. Voltage across capacitor, this subscript C means capacitor. So for this circuit, according to Ohm's law, if you recall, we have V is equals to I R. So if we make R the subject of the formula, we have V over I. So for this circuit, our R also is the same thing as Z, which we call the impedance. And the definition is the same as resistance, which is the opposition to current flow. Opposition to current flow. To current flow. It is also measured in ohms. It is measured in ohms. Okay? So where I have my array, I'm just going to substitute and put Z. This Z means impedance equals to VRMS by RMS. I want to believe that is very clear. Now, for a circuit containing resistor and capacitor, the impedance Z, is equals to square root of R squared plus the reactance across the capacitor, which is AC squared. So here's the formula. Z, impedance, is giving us this. While the total voltage, combined voltage, the total voltage in this circuit, V, or the effective voltage, is giving us voltage across the resistor plus the voltage across the capacitor squared. So let's take note of that. Take note of this. Take note of this formula and this formula also. To calculate the combined voltage, the effective voltage in a resistor and capacitor circuit, we have V is equals to V subscript R squared plus V subscript C squared. V subscript C is the voltage across the capacitor, while V subscript R is the voltage across the resistor. Likewise, in this case, when you are asked to find the impedance, R stands for the value of this resistor here. They will give you a particular value. While here, X subscript C is the reactance of the capacitor. Quickly, let's look at this example, which says the resistance in a series RC circuit is 5 ohms So I'm going to write our resistance is equals to 5 ohms. If the impedance of the circuit is 13 ohms, don't forget, this is the impedance, this is the resistance. Impedance Z is equals to 13 ohms. So the question says calculate the reactance of the capacitor. Reactance of the capacitor. So that's what we have to find. We have two formulas for calculating reactance, depending on what we are given anyway. We could either use Fc is equals to 1 over 2 pi Fc, or this. Depending on what you are given. So if you look closely, you will see that we have our R, we have our impedance, and that makes it easier when using this particular formula. Instead of this, we don't have frequency, we don't have capacitance, so we can't use this. So we can't use this formula in this case, but rather we use this. So we have Z, which is our impedance, is equals to square root of R squared plus XC squared. Our R here is 5 squared, XC squared we don't know. I'm just going to leave it. Our Z, which is impedance, is 13. So 13 is equals to square root of 25 plus X squared. So I need to remove the square root sign by squaring both sides. Squaring both sides. So I have 13 squared is equals to square root of 25 plus X squared. Squared. Don't forget I said we square both sides. This square here cancels the square root. And then I have 13 squared, which is 169, is equals to 25 plus X squared. So I have 169 minus 25 is equals to X squared. This gives me 144, which equals to this. My Xc therefore is square root of 144, which equals to 12. This is the reactance, Xc. X subscript C. Reactance, impedance, and resistance, they have the same unit, which is ohms. All of them measures opposition to current flow. So our reactance, X subscript C, is equals to 12 ohms, which answers the question. I hope this is very, very explanatory. Another thing we'll consider now is AC circuit containing resistor and inductor. This is what the circuit diagram looks like. This symbol here is our resistor. This coil here is our inductor. This is the induction coil. This symbol here represents alternating current. This is the inductor. and this is the resistor. So just like I said earlier, according to our Ohm's law, V is equals to IR. So when we make R the subject of formula, we have R equals to V over I. And I said R is the same thing as Z, which is called impedance, which equals to R is equals to Z, which is impedance. So for this kind of circuit that contains resistor and an inductor, our impedance is going to be R squared plus L squared, where L is equals to inductance, and it is measured in H, area. R is the resistor in ohms, while Z also, opposition to current flow, is also measured in ohms. Okay? So for this circuit containing resistor and inductor, our combined voltage or effective voltage, that is V, is the same thing as voltage across the resistor plus voltage across the inductor. So take note of this. Take note of this. Take note of this. And also take note of this, Z. A quick example here is a circuit consists of a 10 ohm resistor. A 10 ohm resistor. 10 ohm resistor. R equals to 10 ohms and a 0.8 H inductor, which is L. The inductance here is 0.8 H. The unit of inductance is area, which is H. Don't forget that. Connected in series to a 240 volt, that's the voltage. 240 volt and 60 hertz. That's our frequency, 60 hertz. Frequency is measured in hertz. So the first question says, draw the circuit diagram of the arrangement. That's very simple. So we are just going to draw the circuit diagram. With what we are given, you will observe that this is a resistor and an inductor circuit. So I'm just going to go ahead. This is my resistor. So this is what the circuit looks like. The resistance here is 10 ohms. Inductance there is 0.8 Henry. Here I have 240 volts and 60 hertz. So this is the circuit diagram of the arrangement. Circuit diagram. Of the arrangement. You can see it's very, very simple. Okay, so We move to the next question, which says, calculate the inductive reactance. The inductive reactance. Inductive reactance is given as XL. And we know our XL has two formulas, which is XL equals to 2 pi FL, or we could use Z is equals to square root of R squared plus XL squared. So whenever we have the impedance and then the resistor, the second formula here, this here is applicable. But in this case, we don't have Z, which is the impedance. We have R, but we don't have Z, so we can't use it. We have R, we have L. With L now, we have F. We know our pi to be 3.142. So this formula is applicable in this situation. So I'm just going to substitute my value. 2 pi is 3.142. My frequency is 60. L is 0.8. So this is going to give me 301.63. And I told you that reactance is the same as opposition to current flow, which is ohms. It has the same unit as resistance. So our XL here is equal to this. I want to believe that is very, very explanatory. So we move on to our impedance. To find the impedance of the circuit, that is Z, is equals to square root of R squared plus XL squared. So this will be very easy now, since we now have our XL. So we just impute it. And this gives me R squared, which is 10. So I have 10 squared plus this 301.63 all squared. And that will give me 10 squared will give me, that's 1000 plus the square of this. By the time we find the square root, I'm going to have 301.8 ohms. 301.8 ohms as my impedance. So going to the last part of the question. Which says capacitance of a capacitor that must be connected in series with this component to obtain maximum current. Maximum current. In order to obtain maximum current, the question says we should find the capacitance to obtain maximum current. So take note that at resonance, that is where we have maximum current. Maximum current occurs at resonance. And for resonance to occur, Xc must be equal to XL. We said to obtain maximum current. So to obtain maximum current, Xc must be equal to XL. So Let's go ahead and find our capacitance. Our XL from here is this, which is 301.63. XC, you recall this formula. You recall that our X is equal to 1 over 2 pi FC. So I'm just going to use that. 1 over 2 times pi. Our pi is 3.142 times the frequency, which is 60. C is the capacitance we are asked to find. We don't have it, so I'll just multiply it by that. Cross multiply. I have 301.63 times 120, that's 2 times 60, give me 120, times 3.142 C is equals to 1. So if I make C the subject of the formula, this is what I have. 301.63 times 120 times 3.142. I want to believe this is very clear. Okay. So this will give me 8.8 times 10 raised to the power minus 6 farad, because it is capacitance. And another way I can write this is 8.8 times 10 raised to the power minus 6 is equivalent to micro, this symbol. So 8.8 mu is less than 10 raised to the power minus 6 farad. So my capacitance is therefore, so the capacitance C at maximum current is equals to this, or you write it as this, and it is measured in farad. Please, let's take note of that. Another case is that of AC circuit containing resistor, inductor, and capacitor. That's the RLC circuit, resistor, inductor, capacitor. As you can see, this is an RLC circuit. This symbol here, this is our resistor, here is the inductor, and here is the capacitor. This symbol here represents alternating current. Usually they will give us the voltage and the frequency. Okay, so for this type of circuit, our impedance Z is equals to Vrms over Irms, and Z is giving us square root of R squared plus XL minus XC all squared. It is measured in ohms. The unit is in ohms. Use the unit in ohms. Likewise, the effective voltage of this RLC circuit is given as V is equals to square root of V subscript voltage across the resistor, plus voltage across the inductor and voltage across the capacitor. Voltage across the inductor. Voltage across the capacitor, all squared. Likewise, our phase angle is giving us tan theta is equals to VL minus V across the capacitor over V subscript R. And for this type of circuit, this is what the Phasor diagram looks like for voltage. Here we have V subscript C, V subscript L, and here is V subscript R. So this is the Phasor diagram. This diagram here is called the Phasor diagram. For the voltage or voltages in an RLC circuit. Calculate the capacitive reactance. Capacitive reactance. Now X subscript C. X subscript C is equals to 1 over 2 pi FC. So 2 pi times our F here is 160 over pi. Our C is equals to 4 mFarad. So I'm just going to rewrite it here. XC, X subscript C is equals to 2 pi times 160 over pi times 4 mFarad. That's 10 raised to the power minus 6. So pi here cancels pi, and I have 1 over 320 times 4. 1 over 320 times 4 times 10 raised to the power minus 6. So that will give me 781.125 ohms, which is my capacitive reactance. So we have done justice to the second question, which says find the capacitive reactance. Okay. The third one here says inductive reactance. Inductive reactance, which is XL, and that's 2 pi FL, 2 pi F. Our F here is 160 over pi, and our L is 3. This cancels this, so I have 320 times 3, and that will give me 960 ohms. So my inductive reactance here is 960 ohms. So the impedance of the circuit Z is given by R squared plus XL minus XC all squared. Our R is 100 squared. Our inductive reactance, which we got earlier, was 960, and the capacitive reactance was 781.35 0.1 all squared. So 100 squared will give us this 960 minus 781.1 will give us 32041, and the square root of this is going to give us 205 approximately in ohms. This is impedance. Impedance is measured in ohms. Impedance is also the opposition to the flow of current, just like reactance. Reactance across the inductor, across the capacitor, the resistance and impedance, all of them are measured in ohms. The impedance is the overall resistance, is the overall opposition to the flow of current in an RLC circuit or in a resistor and inductor circuit. It could be also in a resistor capacitive circuit, resistor inductor circuit, or resistor inductor and capacitive circuit. So impedance Z is the total opposition to current flow in either this circuit or in this circuit or in an RLC circuit. I want to believe that is explanatory. Okay, so lastly, we are asked to find the current in the circuit. We've done this. So let's find the current in this circuit. We just apply our V is equals to I R. So current is equals to V over R. But the R that we are using in this case is the Z, the overall resistance. So the total current in this circuit will be the voltage over the overall resistance in the circuit. So that's why we are using Z. Our V here is 100. The overall, which is 205. And that will give me 0.488 ampere. Current is measured in amp. Current is measured in ampere. So the current in the circuit is 0.488 amp. Another concept I'll be talking about is resonance in an AC circuit. Resonance occurs in an AC circuit at maximum current when the AC circuit is supplying maximum current. And usually the frequency at which this happens is called resonance frequency. So resonance So at resonance, XL equals to XC. These are the very important things we need to know. XL is equals to XC, that's reactance across the inductor is equals to reactance across the capacitor. Another thing is that VL, voltage across the inductor, is equals to voltage across the capacitor. So at resonance, take note that we have current to be maximum. At resonance, current is maximum. XL equals to XC, VL is equals to VC. And there's a particular frequency which we call the resonance frequency. At this frequency, that is when maximum current flows in the circuit, and that is given as F naught equals to 1/2 pi square root of LC. So in case you are asked to derive this, it's very easy. The frequency at which XL is equal to XC. So I'm just going to do it here, is equal to XC. We know our XL is 2 pi FL is equals to, this one is 2 pi FC. So when you cross multiply, we have 4, 2 times 2 is 4, pi times pi, pi square, F times F square, we have L and C is equals to 1. We want to make F the subject of formula. So we divide both sides by 4 pi square LC. When we take the square root of both sides, we have F is equals to 1/2 pi. Square root of 4 is 2. Square root of pi square is pi. Then we are left with square root of LC. You can see. So this is our resonance frequency. Resonance frequency. It is the maximum frequency. It is the frequency at which maximum current occurs in an AC circuit. Resonance frequency. Aspect of this topic now is power in an AC circuit, which is given by P is equals to I V cos theta or I square R. So I'm going to define the terms. Our I here is the current measured in ampere. V is the voltage measured in V volts. Cos theta. Okay, I'm going to just split them. Theta is the phase angle. R here is the resistance measured in ohm. Cos theta is the power factor, which is also given as R over Z, resistance over the impedance, power factor. So quickly, let's look at this example here. It says, calculate the average power dissipated in an AC circuit with an RMS current of 5 ampere. High RMS is equal to 5 amp, voltage of 10 V, and the phase angle is 60 degrees. So the question says calculate the power dissipated, which is very straightforward. P is equal to I V cos theta. Our I is 5, V is 10, cos theta is 60 degrees. So this is 50 cos 60, that's 0.5, and this will give you 25 watts. Power is measured in watts. So our P is equals to power dissipated in the AC circuit is equals to 25 watts. Energy stored in an AC circuit. This is given by E is equals to half Li squared, where L is the inductor or the inductance. I is the current. This is the inductance. It's as simple as that. Half Li squared. And the unit. The unit of energy is joules. So let's quickly examine this example. A direct current of 0.5 is direct current of 5 ampere. Current is 5 ampere. Flows through 0.2 Henry inductor. So the question says calculate the energy stored, which is E. So we just apply our formula, which is half Li squared, and that will be half times our L is 0.2, I squared, that's 5 squared, half times 0.2 times 25. I can write my 0.2 as 2 over 10. You know, this cancels this. 5 here to 5 here 5. So this gives me 25. Sorry, this gives me 5 over 2, which equals to 2.5 joules. So E, the energy stored in the inductor is equals to 2.5 joules. I want to believe this is very, very explanatory. So here are some exercises that I would like you to attempt. Thanks for watching. See you.